Okay, so we'll just walk through a really quick example of how you would solve a systems of equations using Numpy. You can see here that I've got the same convention that we used in the last section. Hopefully you coded along with the snippets. You're going to import Numpy as NP, and then you call it using this NP dot argument. And so I've got two arrays here. I have an A matrice and the B matrice, and you'll see these have the same values as the numbers that we had plugged in and solved using substitution in the few videos ago. So if I go ahead and run this, this creates the two arrays, and then I can look and see what each of these arrays look like. You can see I've got this 2 by 2 matrice. I do want to point this out so it's not lost on folks. When you create an array in Numpy, you see how you've got the outer brackets that create the array and the inner brackets separated by a comma that create the rows. You can reshape a list if you want to. So for example, if I wanted to get rid of these inner brackets, I run this again and print, I've got now a one row matrix, and I could do a reshape 2 by 2, right? And then it gives me this reshaped array. However, let's keep it how we had it. And then I don't have to reshape. Okay, so I also want to show you what B looks like, and B looks like the same. Okay, so there is a system in place so that you don't have to figure out how to take an inverse of a matrice, which can be a fairly tedious thing to do if you've ever taken a linear algebra course. We're going to let Numpy handle that for us. So we know we've got this system, and we want to solve for x. In order to solve for x, we have to do some calculations. So what I can do is I can take this Numpy argument, lin alg dot solve, and I just put in these two arrays. I hit go, and you can see that it returned us -3, 4, which are the same values that we had calculated using the substitution method. But obviously here I did it in a couple of lines of code to build the arrays, and then only one line of code to solve. And this is actually very, very efficient. So if I were to make these arrays significantly larger, as long as they kept with the convention of matching the rows and columns correctly, this single line of code to solve this system is very powerful and works at significant scales. Okay, so now it's your turn. I'm going to give you a set of applications, and you're going to code up and solve some of your own systems. Good luck.